All right. Help me welcome Shane, everyone.
Welcome. I'm Shane Pearman, and I'm a developer contributor to the Reticulum-rs port of Reticulum, which is originally Python. And I think it was presented here at FOSDEM maybe 2 or 3 years ago, but I think many people are familiar with it already. The Reticulum-rs port was initially started by Maxim Ostapenko, and Jochen Muller is another of the major contributors there. I think most people are familiar with mesh networking, but I'll just briefly touch on it. As opposed to like an internet protocol where the networks are arranged more hierarchically, the mesh networks can be any general topology. And in this case, in the case of Reticulum, any of the nodes are going to be relaying packets, whereas with traditional networks, you'll have usually a backbone or your routers, and then other devices are just going to be clients, not necessarily doing the relaying. Some of the uses for mesh networking that are seen commonly are ad hoc networks that you need to set up, for example, in disaster scenarios. A couple of years, or last year, I think it was in Spain, there was a power outage nationwide, so you had no cell service, and that lasted about 8 to 10 hours. So this would be a way to keep connected with your devices as far as needing to keep connected with emergency services and response. And it also sees applications with IoT deployments where you have a large number of nodes. So Reticulum was created by Mark Kvist, and he has actually a pretty good talk on YouTube where he goes into detail about its design and the design philosophy. The best way to find information is the reticulum.network website, and then the community is based around the reticulummatrix.org chat. So that's the best place to get more information. And the reference implementation in Python is on GitHub. So Reticulum, I guess what makes it different or makes it stand out from other mesh networking solutions would be that it was designed from the start, assuming that any peer or link or node in the network could be potentially compromised or hostile. By default, everything is going to be end-to-end encrypted, and forward secrecy is available by default. The identities on the network are based around public key pairs. You have a X25519 key for key exchanges, and then you have a ED25519 key for signatures. And each identity is going to be based around those keys. You don't have to appeal to any certificate authorities for authentication or validating. The API is message-oriented already, so it's very easy to develop applications. Some additional points in Reticulum: all packets do not have a source address. It improves privacy and censorship. It's more censorship resistant in that way. The addresses, whereas with traditional IP, internet IP, addresses are going to be bound to like your location, or depending on, for example, with Reticulum, you're able to generate as many addresses as you want from that key pair that is your identity. And one of the benefits of Reticulum is that it's designed to work very well in high latency environments and with a very low bandwidth. I think the bit rate that Mark usually cites is you need about 5 bits per second to maintain a connection to a peer. And that's a trade-off based on like how long you want the timeout to be for the link, but they settled on about that, which is 5 bits per second. So the port to Rust was started based around performance issues with the Python implementation. There is a messaging app for Reticulum already that supports mobile, but it's very slow on Android. Running Python on Android is not very optimal. And in addition, CPU overhead prevents it from being used in very small devices, microprocessors, for example, with IoT devices. So with regards to maybe keeping the Python implementation and trying to optimize it, that would be very challenging. I don't know if JIT compilation would be very useful here. I know I've used Numba for some optimization in Python, but for a mature code base like Reticulum, it could be very difficult or not maybe not too effective. Reticulum uses, the Python implementation it links to C libraries. There is the option to use Python native cryptography primitives, but mostly it's going to be linking to like OpenSSL. So that should already be very optimized, but the code around that, which is in Python, which would be like the routing logic, is going to be harder to optimize. And there's the issue of the interpreter lock with Python and also garbage collection. This image here just is pointing to part of the object graph. When you're running Reticulum, there are a lot of references, back references, and circular references. It can be difficult to really pin down like where data is getting used. So we've evaluated a few languages, looking at C+. C++ has cryptography libraries, but being C+, there are a lot of differences with the build system. API, like the APIs can differ quite a bit, and packaging and including dependencies in your C++ projects. Zig is a newer language, so it's still not quite mature. Another language that might fit here would be like Golang. So I wasn't actually, at this stage of this project, I wasn't on the projects. I don't know if Go was considered, but we settled on Rust for being a memory-safe language and having available cryptographic libraries, and also cross-compilation for Android, as well as being able to run on embedded targets. So that was the part of the impetus there. Just an overview of going from Python to Rust, getting rid of the circular dependencies, making it easier to test and scale. So the initial implementation there is on GitHub. This is just an outline of the public modules for the library. So far for the interfaces, there's TCP and UDP, and Chaonic is a frequency hopping radio that's being developed. I guess while I'm on this, in Reticulum, the connections between peers are links. That would be the upper right there. And destinations are basically your addresses. One Reticulum node is going to have to handle a lot of connections and I/O from multiple sources, depending on how many interfaces you're running. So, for example, here is I believe this is from the UDP interface. So, receiving data on the socket, as well as sending data out at the bottom there. And each of these are going to be running in separate tasks. So, the Python implementation does not use async, whereas with Rust, we settled on using the async runtime. So that fits pretty well for helping the scale to async, and having both input and output at the same time allows you to interleave that very well and makes it very efficient. It also has to do packet routing at the same time, checking with whether the packet needs to be forwarded or if it needs to be handled locally. Yeah, managing peer sessions, so keeping track of the state of your links, which are the connections to peers. So in Rust syntax, I think I don't really program JavaScript, but I think it's similar. We have the await keyword are the async methods. And link management is another example of something that needs to be done concurrently. So here, yeah, actually there's not too much to show here, but yeah. As far as the difference in the architecture goes between Python and the Rust implementation, the Python implementation, the public-facing API, is going to be using callbacks mostly for when data comes in and you want to read the message and reply, as one example. That means you have to go through setting up. So for the destination, when the connection gets established, you need to set a callback first for when it gets established. When it gets established, then you just set another callback for when the data comes in, and then that's at the top there. And even more, like if you wanted to do something when the link drops, you'd have to set another callback there. Whereas with the Rust implementation, we're just going to have channels here. So you just subscribe to a broadcast channel. And this is also an async channel. It works well with the async runtime. And you're able to just wait for events. And then depending on what event happened, then you can proceed from there. So yeah, I think Rust is also pretty well known at this point. It's been around for a while, and it's fairly popular. Going from Python, which is not necessarily typed, there's gradual types or type hinting available, but at least in the Python Reticulum library, it's not really used. Moving to Rust, the type system helps quite a bit with making sure things are correct. These are just some of the design patterns that Rust allows with its type systems. From the Reticulum-rs implementation at the top here, you have a few different, it's like a state machine. depending on what state you're in, you're going to have a separate type, so it prevents errors. Whereas, for example, if you're just dealing with raw as ciphertext or something like that. This is also an example of the new type pattern, so it's just a very light struct wrapping some data. It's a little bit confusing because of the lifetimes, but the main thing to note is just it's a struct wrapping an array of bytes. The builder interface pattern, actually, I don't think it's used in Reticulum-rs right now. You'd probably run into it like when you're initializing the logger. And phantom types, for example, in the Rust-rs implementation, we have destinations and they're parameterized by different types. And this allows you to, for example, have a type of method overloading. Rust doesn't have method overloading, but it has a trait system. You're able to, depending on which type you plug into these different type parameters, you can overload what the trait implementation does. So the benchmarks are not too surprising. The base memory usage going from Python to Rust was from 30 megabytes to 4 megabytes. I think that's pretty typical. And on the CPU task clock, from 51 milliseconds to 4. And this was just like a basic perf test on Linux. The current state of the implementation, we have identity, links, transport, and channels are a work in progress. And the roadmap is getting this able to run in embedded environment. That's going to be a large one. Configuring interfaces. So right now, the Python implementation has a configuration format, it's not TOML, it's similar to TOML. So there's some work being done right now on converting that to TOML, so it'll be standardized, and then maybe make that readable by the Reticulum-rs implementation. Another feature of the Python implementation that is missing in Rust right now is resources, which is a method for sending large files, and key ratcheting, so that's the forward secrecy part. Yeah, I think getting this on embedded is going to be one of the main challenges. So we have been running it on smaller microprocessors, but to get it into the very smallest microcontrollers will require some rewriting. And there are available async runtimes. There are two that I'm aware of, which is the Embassy and RTIC runtimes. It's sounding, Embassy is more complete, but I'm not sure yet. So I think there still remains challenges with concurrency in Rust, even though it has memory safety and you avoid a lot of the pitfalls of C and C+. You can still run into issues like deadlocks. So doing that correctly is going to be a challenge. As far as, because this is so motivated by performance, I'm not sure yet how profiling will be on async. So I've done profiling for Rust, but not with the async runtime. Yeah, that'll be seen. And maintaining compatibility with the Python implementation. So we're testing against the Python reference implementation, but as that develops, I think it's in 1.0 now, like within the last year. So hopefully it's relatively stable, but we'll want to maintain compatibility going forward. Some of the applications that we've been testing with. So this is a VPN application using a virtual TON interface on Linux. And that allows you to basically route just your standard TCP/IP applications over Reticulum. Another application that we've been working on is using Reticulum with drones. So Mavlink is a standard for communication with drones. And this is what we've been testing on the STM32 microprocessor with Yocto Linux. We also have some development on a messenger for Android. And I think I'll leave it there for, GitHub repo link is there. If you want to reach out, there's an email there. And that's it,
All right, we have time for a few questions. Here we go. I see a hand up here, and then I think there was a question here. Okay. There we go.
Hi, thank you for your talk. It's very interesting to see a Rust implementation of the node and Reticulum. I wanted actually two questions. One is, do you plan to support our node on LoRa as well? And the second one is that, this be a different kind of compatible implementation with Reticulum, or since Markivist has altered public development, you're going to try to take over or continue his lineage?
So you said the first part was about LoRa, right? Correct? So LoRa, there is not currently, as you saw, there is not currently an interface. As far as I know, it's not on a roadmap for me, but it's open source, so hopefully somebody can contribute. It's not very hard to implement the interfaces. And then, sorry, what was the second part of the question?
Sorry. And yeah, actually partially answered the second question as well. The second question was, does it mean to be protocol compatible with the Python version, or will be, since the archivist has halted public development of the Python one, if you're going to take over his lineage? And
so you're referring to like where recently he stopped, it's like a mirror now.
Yeah, it was expected somehow because already announced, I believe 1 year ago or something, that it was completely tired.
So was your question, are we going to be taking that over, or?
Yeah, something like, would you re-implement the full stack in Rust, or it just is something like two separate implementations that are compatible with each other?
Right. Basically, they're two separate implementations that are compatible with each other. Right now, the Rust implementation is about 5,000 lines, whereas the Python has about 30,000 lines. So there's still quite a bit to do. We've just basically implemented what's necessary to get it working. So, yeah.
Theo, thank you very much for your work. What were the biggest things you learned about Reticulum which were not documented anywhere while you ported it to Rust?
So I'm not sure exactly specifically, but I remember him mentioning 55,000 nodes or something would fit in like a megabyte or something like that. And then I tried doing the math on that because I saw that comment in the code, and I looked at the path table. The sizes didn't really match up, so I don't know if that's still true. So that was just something that came out when I was looking at the code. So yeah. I've actually worked more on the application side, so I've contributed like an interface, and I do like code review for the Reticulum-rs code, but I've worked mostly on the applications.
Another question. Reticulum 1.13 now depends on LXMF to do stamp verification for announced interfaces. Do you think it's a good idea that there's a circular dependency now between RNS and LXMF?
So LXMF is like the messaging?
Yes, and LX stamp is what does the proof of work. And now in the newest release, RNS depends on LXMF.
Okay. Yeah, that's a good point. I'm not too familiar with it, so I couldn't really say. Yeah.
All right, and if there's other questions, feel free to talk to him after, but we are going to keep things moving along now. Let's give another round of applause, everyone. Thank you very much.
Thank you.
All right, we're going to get set up for the next talk now. Give us just like 1 minute, and we'll get going again. Oops.